So for the first question, we've got a multiplying decimals question. Now the key thing here is what I want to do is turn these numbers into integers. So 2.98, if I multiply that by 100, that becomes 298. And 3.7, if I multiply that by 10, that becomes 37. I can then use any multiplication method that I like in order to multiply these two numbers together. You can use the grid method, you can use the lattice method, you can use whatever you want. I prefer Napier's bones, I just think it's fun. But you choose whichever way you want. So the way we do Napier's bones is it's a 3-digit by 2-digit number. I'm going to multiply, so therefore I create a 3 by 2-digit box. So I've got 298 multiplied by 37. I split the box into two, so I have a diagonal splitting each little box into two parts. And the way it works is in the top part, you write your tens, and the bottom part, you write your units. So the reason this method is good is because you're only ever multiplying single digits. So if you're great with your times tables, but you sometimes get confused with other kinds of multiplications, this is a really great way. So first we're going to do 8 times 3, which is 24. So I put the 2 for the tens and the 4 in the bottom one. 8 times 7 is 56. 9 times 3 is 27. 9 times 7 is 63. 2 times 3 is 06 because there are no tens. 2 times 7 is 14. So that's the only multiplication I'm going to have to do. Then I go along every diagonal. So under this diagonal, everything adds to 6. In this diagonal, I've got 3 plus 5 plus 4. So 8 plus 4 is 12. I carry the 1 into the next box. Then I do 7 plus 2, which is 9, plus 6 is 15, plus 4 is 19, plus 1 is 20. So I'm going to carry the 2. Then I've got 6 plus 2 is 8, 9, 10, 11. So I write 11 and I carry the 1. So my final answer here is that 298 times 37 is 11,026. So if I know this, there's either the shortcut method, which is you just count how many digits there are after the decimal point, and your final answer needs to have that many digits. So I know that 298 times 37 is 11,026. Then I've got 2.98 times by 3.7. So there's 2 digits here, 1 digit here. So in total, I know my answer is going to need 3 digits after the decimal point. So I move it accordingly. So that would be 11.026. The other method, which is like how we end up knowing to do this, is that if I've multiplied by 100 and then by 10 to turn this into integers, I've multiplied by 1,000 in total. So when I get my answer, I divide by 1,000. But either way, you choose whichever multiplication method you like, and then you either divide it by the powers of 10 that you multiplied by, or you count the decimal places. And that's how we do multiplying decimals. The next question is dividing decimals, and a really good thing to do is to just briefly recap on what happens when we divide. So if I said, what is 4 divided by 2? I know that is 2. If I multiplied each of these by 10, so 40 divided by 20, that's also 2. If I multiplied each by 100, that's 400 divided by 200, the answer is also 2. So unlike with multiplication, where you have to convert them back by whatever you multiplied by, with division, whatever you do, as long as you've multiplied both parts of the calculation by the same power of 10, your answer will always be the same. So what I can do, and one of the best things to do when we've got something like this, is to actually write it as a fraction. So I've got 63.28 and it's being divided by 1.4. Now essentially what you want to do is you want to multiply this calculation so that the second part of the calculation is a single integer, because then you can just use the bus stop method. But what we could do here is times the fraction by 10. So that would give me 632.8 divided by 14. I can then think to myself, okay, so the denominator is a integer. So now what can I do to get it a single digit? I can divide the fraction by 2 and it becomes something over 7. So if you're not confident with what 632.8 divided by 2 is, you could quickly use the bus stop method. So you've got 2's into 6 go 3 times, 2's into 3 go once, remainder 1, 2's into 12 go 6, 2's into 8 go 4, so that would be 316.4. And then you've got yourself a really nice calculation, which is 316.4 divided by 7. And once again, because it's a single digit, you can use the bus stop method. So 306.4 divided by 7, 7's into 3 don't go, 7's into 31 go 4 times, remainder 3, 7's into 36 go 5 times, remainder 1, and 7's into 14 go twice. So because with division, as long as we manipulate them and as long as we're keeping everything in an equivalent fraction, so we're multiplying the numerator and the denominator by the same power of 10, we don't need to change anything back. And the easiest way to not get confused is to just use the equivalent fraction method. So you're essentially simplifying it until it's something nice that you can easily divide. And your final answer would be 45.2. Okay, next we've got a slightly worded ratio question. So the important thing with worded questions is to just try and extract the information and only take in the important things. So I'm told that there are 75 sea turtles in a turtle sanctuary. A third of the turtles in the sanctuary are green sea turtles. And sometimes it actually just helps. You might prefer to read out the whole question first, or you could just work things out as you go along. So you know that a third of the sea turtles are green sea turtles. So we could start by just working out what a third of 75 is. Now, you might know this in your head. So you might already know that 25 must be green sea turtles. If not, then to work out a third, what does that mean? Well, to work out a third of anything or a quarter, you do a third of 75. What you do is you divide by the denominator and multiply by the numerator. So a third essentially just means something has been split into 3 parts and you want one of those parts. So 75 has been split into 3, so divide it by 3 is 25. Okay, so that's the first bit of information I know. So I know that green sea turtles are 25. Then I'm told the number of green sea turtles in the sanctuary is 5 times the number of leatherback turtles. So I know that the green sea turtles are 5 times as many as the leatherback. So I could do 25 divided by 5, which is 5, which means I know that there are 5 leatherback turtles. The number of loggerhead turtles is 2 times the number of leatherback turtles. So let's write what I know about the loggerhead. So I know the loggerhead is 2 times the number of leatherback. So therefore there are 10 loggerhead turtles. And it's really helpful to just actually write things out when you're doing the question, because it helps your mind just actually see what you've worked out rather than holding everything in. Don't try and hold everything in your mind because you're just giving yourself a cognitive overload. Write things down to signpost it and make it easier for yourself. So I know that there are 25 green sea, 5 leatherback and 10 loggerhead, and I'm told that the rest of the turtles in the sanctuary are flatback turtles. So there are 4 types of turtles in total. 25 plus 5 is 30 and 30 plus 10 is 40. So over here, that equates to 40. And I know that the total is 75. Therefore, there must be 35 flatback turtles. I'm then told that the number of leatherback turtles, so leatherback to flatback, is 1 to n. And I need to work out the value of n. So let's actually write that down. There are 5 leatherback turtles and 35 flatback turtles. And I need to write this in the form 1 to n. So what have I done? Or what have I divided 5 by to get it into the ratio of 1? I've divided by 5. So I need to do exactly the same to the other side. So 35 divided by 5 is 7. So n would equal 7. Whenever you're told to write it in the form 1 to n or n to 1, just write the ratio out and underneath write 1 to n or 1 to something. That's the missing value. and you're just trying to find an equivalent ratio. So all it means is that one part of the ratio has been simplified to 1, and you simplify the other part in exactly the same way. Okay, so here I'm told to work out the highest common factor of 100 and 210. Now, there's a few ways that we can work out highest common factor. You could start by working out the factors of 120 and 210 and then finding the highest one, but sometimes people just miss one out. So the best way to do that is actually by using prime factor decomposition. And especially if you're working out the lowest common multiple, this will be super helpful as well. So if you're asked to express a number as a product of its primes, all that means is to do the factor tree. So you start with 120, and then you're thinking of two numbers that multiply together to make 120. And ideally, one of them is going to be a prime number because that makes your life so much easier. A quick recap, the prime numbers are 2, 3, 5, 7, 11. And they're the first few. They're the ones that you're most likely going to be using. You'd first start with 2, then 3, then 5, then work your way. So 120, I know, is 2 multiplied by 60. When you've got a prime number, you circle it and you've extinguished your tree branch. Then I look at 60 and I think of two numbers that multiply together to make 60. I choose 2 because it's a prime number. I circle it, so I've extinguished that branch. So 2 times by 30 makes 60. Again, I keep going. So two numbers that multiply together to make 30, that would be 2 and 15. And then two numbers together that multiply to make 15, that would be 3, which is prime, and 5, which is prime. So once you've got to the prime numbers, they're circled and that's the end. And then all you do is you collect them. So 120 is 2 times by 2 times by 2 times by 3 times by 5. And what that means is if I do 2 times 2, which is 4, times 2, which is 8, times 3, which is 24, times 5, you'd get 120. So you're just decomposing your number into prime numbers. I do the same with 210. So again, you can do whatever you want. You could do 7 times 30. Actually, yeah, fine, let's do 7 times 30. So think of two numbers that multiply together to make 210. 7 is a prime number, and then I've got 30. Then what I do is I continue my branch. 30, two numbers that multiply together to make 30. 3, which is a prime number, and 10. And the way you've done your factor tree does not need to be the same. The cool thing is that whatever you do, you're going to get exactly the same prime factors. So we've got 10, two numbers that multiply together to make 10. That would be 2 times 5. And they're all prime factors. So then 210 equals, and it's good to write them in ascending order. It's not critical, but it's good to practice. So I've got 2 times by 3 times by 5 times by 7. Okay, so you've decomposed your numbers into prime numbers. And then what we want to do is, it's best to do it with a Venn diagram, but you could do it not with a Venn diagram. So you have a Venn diagram. One of the circles is for factors of 120. The other is for factors of 210. And then anything that is in common to both of them, you put in the middle. So I've got 2 here. So I'm going to put 2 in there once. I've got a 3. So I'm going to put 3 in. And then I've got 5. So that's all the numbers that I have in common. What's left over is 2 and 2 and 7 for 210. So to work out the highest common factor, what you do is you multiply all of the numbers inside the intersection. So that would be 2 times 3 times 5, which is 6 times 5, which is 30. And if you were to do the lowest common multiple, then you'd multiply everything inside the Venn diagram. So that's how you'd work out the LCM, but the highest common factor is 30. Okay, next I've got a question that sometimes it just trips people up because you're so busy thinking about the next question that you don't bring it back to real life knowledge. So I'm told that it would take 140 minutes to inflate a bouncy castle using the air from 4 fans. How many long, that's supposed to say how long, will it take to inflate the bouncy castle if 5 fans are used? So what I do is I know that 140 minutes is how long it takes for 4 fans. Now, just like builders, if you were building a house, the more people that helped you build that house, the quicker the house would get built. So that's an inverse relationship where when one thing increases, the other decreases. And this is the case here. If you had more fans blowing air in, more air would go in at a quicker rate. So therefore the bouncy castle would get blown up quicker. So when I've got inverse proportion, whatever I do to one variable, you do the inverse to the other. So let me tell you what I mean. So we know that 140 minutes is how long it takes for 4 fans. And what you could do is work out how long it takes for 1 fan. So how do you get from 4 to 1? You divide by 4. So you're going to need to do the inverse operation on the other side. So inverse proportion is the direct opposite of direct proportion, where what you do to one side you do to the other. So here I'm going to multiply by 4. So 140 times by 4, you can use whatever method you like. 4 times 0 is 0, 4 times 4 is 16, 4 times 1 is 4, plus the 1 is 560. So I know that if only one fan was blowing air in, it would take 560 minutes. So then the question has asked me to figure out how long it will take to inflate the bouncy castle if 5 fans are used. So what would I have to do? Well, to get from 1 fan to 5 fans, that's 5 times the amount. So I'm going to times by 5. And over here on this side, what I'm going to have to do, because it's an inverse relationship, I'm going to have to divide by 5. So 560 divided by 5. 5s into 5 go once, 5s into 6 go once, remainder 1, 5s into 10 go twice. So that would be 112 minutes. So the time has decreased by a bit, and it's asking me to give your answer in hours and minutes. So there's 60 minutes in 1 hour. So that would be 1 hour, and then 112 take away 60. 2 take away 0 is 2. 1 take away 6 you can't do. 11 take away 6 is 5. So it'll be 1 hour and 52 minutes. Now the next part of the question is asking me to state an assumption I have made. Well, I'm assuming that all of these fans are blowing out air at the same rate, because one of them, for example, might be a really old one that is a little bit broken, so it might be blowing air really, really slowly. So I'm assuming in order for this to work, I'm assuming all of the fans are blowing out air at a steady rate. So all the fans are blowing air at the same rate. So just like if you were to fill a swimming pool, and everyone had like a different hose, if one of the pipes was a bit weaker than the other, that one would take longer. So you're assuming that everything that is being used for this bouncy castle is working at the same pace. Okay, next we've got a nice Pythagoras question. So I'm told that a rectangular bed frame is made from 5 straight pieces of metal. And there's a diagram here. So it's a rectangle and opposite sides of a rectangle are equal. So therefore I can start filling out some of the information. So now that would be 3 meters and this one would be 4 meters. I'm told the weight of the metal is 1.2 kilograms per meter. And I need to work out the total weight of the metal used for the bed frame. Well, in order to work out the total weight, I need to work out how much metal is used. So I know there's a key here. There's 5 straight pieces of metal, which means you're going to need to work out this length here. So it's a rectangle divided into 2, forms 2 triangles, and it's a right angled triangle that is shown here. Whenever you've got a right angled triangle, you know automatically that you could use either Pythagoras or trigonometry. Now, if you have a right angled triangle and you've been given 2 sides and you're trying to work out the third side, you know that you can use Pythagoras. So Pythagoras is a squared plus b squared equals c squared, where the squares of the 2 sides add up to make the square of the last side. just a quick little recap if you've forgotten. The reason we do this is because the area of this square plus the area of this square would equate to the area of this square there. So you might remember doing it that way. So I'm going to do that to work out the side. So I know a squared plus b squared equals c squared. A squared is, it doesn't matter. So a and b are the shorter sides, and c is always the hypotenuse. And the way you identify which one is the hypotenuse is it's the diagonal one. It's the side opposite the right angle. So that's how you know whether you're going to have to add or subtract, because c is the longest side. So a and b, it doesn't matter which one you label, whichever, they're both the shorter sides. So you've got 3 squared plus 4 squared must equal c squared, and c is this length here. So 3 squared is 9, 4 squared is 16, that must equal c squared. 9 plus 16 is 25, so 25 equals c squared. And then if c squared equals 25, to work out c, you're going to need to do the square root. So c is the square root of 25, therefore c equals 5. So I know that this length here is 5 meters. So the total weight of the metal used, I'm going to have to add all of the lengths together. So I've got 4 plus 4 plus 3 plus 3 plus 5. That's 5 lengths. So 4 plus 4 is 8 plus 6 plus 5. You've got 14 plus 5 is 19 meters. So you know that the total length of all of the wires is 19 meters, and you're told that the weight of the metal is 1.2 kilograms per meter. So what you're going to need to do is multiply that by 1.2. For 1 meter, it's 1.2 meters. For 19, you're going to have to do 19 times 1.2. So once again, we could do, so we're going to multiply them. So I've got 19 times 12, turn them into whole number integers, just like we did with the first multiplying decimals question. Then we've got 19 times by 12. So 1 times 9 is 9, 1 times 1 is 1, 2 times 9 is 18, 2 times 1 is 2, plus the 1 is 3. 0 plus 8 is 8, 3 plus 9 is 12, carry the 1, and then you've got 228. So I know 19 times 12 is 228. I'm going to use the cheat method. So 19 times 1.2, there's 1 digit after the decimal point, so that'll be 22.8. So my final answer would be 22.8 kilograms. Okay, next I've got a really nice geometry question. So I'm told that the diagram shows an isosceles triangle, ABD. So this is going to be a key piece of information. What an isosceles triangle means is that it's got 2 equal sides and 2 equal base angles. And the base angles don't always need to be at the base, like over here. The 2 equal sides are here. Therefore, the 2 angles are going to be these 2. These are your base angles. So if this one is x, this one is also going to be x. Okay, so, and the straight line ABC. So it's a straight line, and already over here, I'd be like, okay, it's a straight line, and I know that angles at a straight line sum to 180. So you've got quite a few pieces of information there. I'm told that AB equals DB, which is why it's an isosceles triangle. And then I'm told the ratio of angle W to the angle Y is 5 to 1. And I need to work out the value of X. So first I start by just thinking about, what do I know? I know that that's a straight line. So let's have a look and let's work out what W and Y are. Well, angles on a straight line sum to 180 degrees. And I know that this 180 degrees is split into 6 parts. So 1, 2, 3, 4, 5 parts make up W, and Y is 1 part. So I do 180 divided by 6, because there are 6 parts in total, which is 30 degrees, which means that each of these parts is 30 degrees. W makes up 5 of those parts, so that's going to be 5 times 30, which is 150, and Y is one of those parts, which is just 30. So I know that this angle here is 150 degrees and this angle here is 30 degrees. That's the first part. Then I can use my knowledge of isosceles triangles. So I've got my triangles here. I know this angle here is 30 degrees and I know these two angles down here are both going to have the value of x and they're both going to be equal. So angles in a triangle sum to 180 degrees. So I would do 180, take away 30, which leaves me with 150 degrees. And that means that these two angles here need to add to 150 degrees and they're both equal. So if they're both equal, I can do 150 divided by 2, which is 75 degrees. And therefore, x must be 75 degrees. Okay, next I've got a percentage question. So with questions like these, it's sometimes they seem confusing because you're not exactly sure what they want from you, but if you just read it carefully, that really helps. So I'm told that the price of a spa day increases by 20%. So the price of a spa day was something and it increases by 20%. This 20% increase adds £48 to the price of the spa day. And I need to work out the price of the spa day before the increase. So the really key piece of information that I've been told is that a 20% increase adds £48 to the price of the spa day, which must mean that 20% of the cost of the spa day is £48. So what I can do is I can work backwards. I can use my knowledge of reverse percentages. If I know that 20% is £48, there's two ways actually I can do this. I know that if 20% is 48, I could times it by 5 to work out what 100% is. Or I could just figure out what 10% is by dividing by 2, because 10% is half of 20. So that would be £24. And then to work out 100%, I would then multiply by 10. So that would be £240 is the price of the spa day before the increase. Okay, next I've got the mean from a frequency table. So I'm told that the table shows information about the weekly earnings of 30 people who work in a theme park. And I need to work out an estimate for the mean of the weekly earnings. So you're going to have two types of tables that might come up. It would either be a normal frequency table, in which case over here you just have single values, not an interval. And then you have a grouped frequency table, which is like this. So the first thing we do when we've got a grouped frequency table is we want to work out what the midpoint is. And to work out the midpoint, all you do is you add the two values together and you divide by 2. That's the halfway point. So over here, I'm going to do the midpoint of each of my class intervals. So over here, 150 and 250, the halfway point of that would be 200. The halfway point in 250 and 350 would be 300. Then 400, 500 and 600. All I'm doing is adding the two values together and dividing by 2, but because these ones are nice and simple, I know that halfway between 150 and 250 is 200. And the reason I'm doing this is because there are 10 people that earn between 150 and 250 pounds, but I don't know what they earn. So all 10 of them might earn 150 pounds, or all 10 of them might earn 250. So the best way we can make the best guess is by using the midway point, the average. So that's why I do that. Then what I'd do is I'd create an extra column, which is my midpoint times by my frequency. So I'd do 10 times 200, which is 2000, 8 times 300, so 8 times 3 is 24, add the 2 zeros, 7 times 400, 7 times 4 is 28, add the 2 zeros, 3 times 5 is 15, add the 2 zeros, and 2 times 6 is 12, add the 2 zeros. So the reason I'm doing this is because I'm doing my midpoint, the best guess as to what the earnings are. So there are 10 people that earn £200. Therefore, there's 10 lots of £200, which is 2,000. So I do that for everything. And then to work out an estimate for the mean, so the mean from a grouped frequency table, what I would do is I'd have to do the total of the midpoint times frequency column divided by the total frequency. So generally in these questions, they tell you what the total frequency is. They've told me that it's 30 people, but if they hadn't, I would just add this column up and know it came to 30. I want to add this column up now, my midpoint times frequency. So I could do it in steps. So 2,000 plus 2,400 plus 2,800, 0, 0, 4 plus 8 is 12, 2, 4, 6, 7. So that would be 7,200. And then 1,500 plus 1,200 is 2,700. So I do 7,200 plus 2,700. That gives me 0,099. So I know that the total here is 9,900. And what would I do? Total of midpoint times frequency is 9,900. The total frequency is 30. So that's how I could work out what the mean is. I'm going to keep on simplifying it. So divide by 10 would become 990 divided by 30. No, 990 divided by 3. I could use the bus stop method, or you might already know that that would be 330. Okay, next I've got the laws of indices. So these are just some a recap of all of the, well, some of the index laws that you need to know. So the first thing is that anything to the power of 0 is 1. So therefore 8 to the power of 0 is going to be 1. Next I've got the multiplying indices. So when multiplying indices, you add the powers. So what I'm going to do here is, and just remember that if something doesn't have a power, it means it's to the power of 1. Because if it was to the power of 0, that would be 1. So anything on its own is to the power of 1 because it's itself. So what I'd do is I'd do 1 plus 8 plus minus 8. So 1 plus 8 plus minus 8 becomes 1 plus, and then 8 plus minus 8, that becomes a negative. When a negative and a positive are next to each other, in between the two numbers, they rewrite as a negative, because adding a negative is the same as subtracting. So 8 minus 8 is 0, 1 plus 0 is 1, so therefore that would become 4 to the power of 1. So you've added all the indices together and they come to 1. And it says find the value, so either you write 4 to the power of 1 or just 4. Actually, the value would just be 4. Okay, find the value of 3 to the power of negative 4. So when you've got a negative indice, what it means is it's the reciprocal of what it would be if it was the positive. So I've got 3 to the power of 4. What would that be? Well, if you're stuck, just go back to the basics. 3 to the power of 1 is 3. 3 squared, you times that by 3 is 9. 3 cubed is 27. And 3 to the power of 4, if you don't know it off by heart, then you just do 27 times 3. So as each power increases, you multiply it by itself. So 3 to the power of 4 is 81. Therefore, 3 to the power of negative 4 would be its reciprocal. And the reciprocal is the inverse. So essentially just write 1 over your thing. So that would be 1 over 81. And then I need to find the value of 64 to the power of 2/3. So when you've got a fractional indice, the denominator is what it's going to go to the root of, and the numerator is what it is to the power of. So 64 is going to be to the root of 3. So that's going to be the cubed root of 64. And then it's going to all be to the power of 2. So what's the cubed root of 64? That is 4. So I'm going to be left with 4 squared. And 4 squared is 16. Okay, in this question, I'm told that A over B is equivalent to 3/5 and B over C is equivalent to 2/7. So this is kind of like an equation with ratio. And when I've got something like this, to turn the fraction into a ratio, it's helpful to just write down what each part is. So I know that A is equivalent to 3. I know that B, well, rather, should I say, when A is 3, B is equal to 5. And with my next fraction, when B is 2, C is equal to 7. So the way I can turn the fraction into a ratio is by thinking to myself, okay, when A is 3, B is 5. So when A has 3 parts, B has 5 parts. So that would be the ratio 3 to 5. And over here, the ratio would be 2 to 7. So I know that I've got two ratios. I've got A to B is 3 to 5. And B to C is 2 to 7. So what I notice is that I've got B is common to both of these. So what I can do is set the ratios up like this, A to B to C, and find an equivalent ratio for B. So make them both the same amount, then I can compare the ratios easily. So A to B is 3 to 5, B to C is 2 to 7. What's the lowest common multiple over here of B? The lowest common multiple is 10. So therefore, to turn B into 10 over here into equivalent ratio, 3/5 is equivalent to something over 10. I've multiplied 5 by 2. 3 times 2 is 6. So 3/5 is an equivalent ratio to 6 over 10. So I could write this as 6. So A to B is also 6 to 10. Now I do the same over here. 2 to 7, I want to turn B into 10. So I multiply 2 by 5. So therefore, I'm going to have to multiply 7 by 5 as well. So to turn this into an equivalent ratio, where B is 10, that would be 10 to 35. And now because I've got both of them have 10 in common, I can write all the ratios side by side and they're all comparable. So that would be 6 to 10 to 35. And that's how I do that question. So 6 to 10 to 35 is your final answer. It hasn't asked you to simplify it. So that's how we do that. Okay, next I've got a capture-recapture method. So normally this is with population samples, but in this case it's been given just as marbles. So I'm told that there are X marbles in a bag and that 14 of the marbles are green. So the first thing I can do is I know that a bag of marbles, I don't know how many marbles there are. I know there are X amount of marbles. So that is the total. And I know that there are 14 of them are green. The next bit of information I'm said, I'm told that Abdurrahman takes at random 36 counters from the bag and 6 of these counters are green. So he's taken the sample or like a small amount, a selection from the bag, and 6 out of 36 are green. So again, I've got green marbles here and my sample total. So what I can do, I'm trying to work out an estimate for the value of X. And if I assume that this sample is representative of everything that's in the bag, what I can do is make my fractions equivalent. So I know that 14 over X must be equal to 6 over 36. Now this is a little bit of a tricky one because 6 doesn't multiply easily into 14. So what I could do, because you should be really familiar with just simplifying fractions, I could look at 6 over 36 and simplify it. So if I divide that by 6, divide that by 6, I'm left with a 6th. So therefore 14 over X must be equal to 1/6. And what do I do to turn this equivalent? Well, 1 times by 14 gives me 14. So therefore 6 times 14 is going to tell me what X is. 14 times 6, 6 times 4 is 24, 6 times 1 is 6, add the 2 is 84. So X must equal 84. So the trick is that you compare, you've got your total population or the total amount of marbles, and then you've got your sample size. So you're assuming that however many green marbles there are in your sample size is representative of how many green marbles there is in total. It is just an estimate. He could have picked out nearly all of the green marbles. There might be, he could have picked up anything, but this is how we estimate a population sample, or this is also called capture-recapture. Okay, so here I've got 3 cones, and we're talking about volume. So not always, we haven't been given the formula for volume of a cone. I don't need to use the formula at all. I just need to consider how each cone is changing proportionally compared to the other. And whenever you've been given this, you have 2 options, right? Well, you have many options, but you could either use algebra, or you could just give each cone a random number. So you could say the volume of cone 1 is 10 centimeters cubed. You could say it's 100. You could say it's 400. I noticed that the volume of cone 2 is 25% more. To work out 25%, you know it's a quarter of something, so you're dividing it by 4. So I'm probably going to want to choose something that's easily divisible by 4. So perhaps you might choose 100. Then you know 25% more is 25. But then you need to find 25% more again. So something that would be divisible by 4 again would be great. So I'm just going to use 400. This is just going to make my life easier. It doesn't matter what number you chose. If you chose 100, it just means your next part is going to be decimal, but it doesn't matter as long as you're keeping everything in proportion in relation to it. So I'm going to assume that the volume of cone 1 is 400 centimeters cubed. And then everything must change in relation to that. So I'm told that the volume of cone 2 is 25% more than the volume of cone 1. So 25% of 400. To work out 25%, the shortcut is divide it by 4. So 25% of 400 is 100. So it's increasing. So 400 plus 100 is 500. So that's going to be 500 centimeters cubed. And then the volume of cone 3, I'm told, is 25% more than the volume of cone 2. So cone 2 is 500. 500 times by 1.25 you could do, or again work out what 25% is and add it on. So 25% of 500 is 500 divided by 4. 4s into 5 go once, remainder 1. 4s into 10 go twice, remainder 2. And 4s into 20 go 5. So I'd do 500 plus 125 is 625. So 625 centimeters cubed. This obviously isn't the actual volume of the cone. I don't know what the volume of the cone is, but using equivalent fractions, it's going to be the same proportionally. So I need to find the volume of cone 2 as a fraction of the volume of cone 3. So cone 2 is 500, cone 3 is 625. So that would be 500 over 625. Then it says write your answer in its simplest form. So what I would do is simplify my fraction. So 500 over 625, I can start by just dividing by 5. So 500 divided by 5 is 100, and 625 divided by 5. 5s into 6 go once, remainder 1. 5s into 12 go twice, remainder 2. And 5s into 25 go 5. So that'd be 125. Then I can divide by 5 again. So 100 divided by 5 is 20, and 125 divided by 5 is 25. Again, I can divide by 5. So 20 divided by 5 is 4, and 25 divided by 5 is 5. So volume 2 is 4/5 of volume 3. Okay, so in this question, I'm told that the table shows a set of values for x and y. And I'm told that y is inversely proportional to the square of x. So inverse proportion is where when one variable increases, the other decreases. And usually when I've got something like this and I'm told something's inversely proportional, I can set up a statement for myself. So the way I do that is by saying y is inversely proportional to the square of x. Now the square of x means x squared, and inverse proportion is where it's like the reciprocal. So if I said y is proportional to x, it would look like that. But if y is inversely proportional to x, it would look like that. And this little sign here means is directly proportional to. So technically that statement says y is directly proportional to x, and this one here says y is directly proportional to the inverse of x. But either way, you write your setup statement, and then we write our equation. So y isn't actually equal to the square of x, it's proportional to the square of x, which means it's going to be something divided by x squared. And I don't know what that something is. And what I do is I work out the value of k by substituting the values in. So I know that my equation is going to be y equals k over x squared. I am going to substitute any values in. So when x is 1, y is 16. When x is 2, y is 4. I could substitute any of these values in, it doesn't matter. I'm going to do 1 and 16. So when x is 1, y is 16. Therefore 16 equals k over 1 squared. So 16 equals k over 1. And that must mean that k equals 1. K equals 16. So what I do is I draw out my statement, write out my equation, and then I substitute values of x and y into it to figure out what k is. So I know that k is 16, therefore my equation is going to have to be y equals 16 over x squared. Then I'm told to find the positive value of x when y is 9. So the positive value of x when y is 9, I'm going to use this equation. So y equals 16 over x squared. I'm going to substitute y as 9. So 9 equals 16 over x squared. Let's rearrange it. So that would mean that 9x squared equals 16, because I multiplied both sides by x squared. Then I would divide both sides by 9. So x squared would equal 16 over 9. And to finish it off, I need to find the square root. So x would be the square root of 16 over 9, which could be written as the square root of 16 over the square root of 9. And I only want the positive square root, so the square root of 16 could be plus or minus 4. And the square root of 9 would be plus or minus 3, but I only want this positive, so that would be 4 over 3. So x is 4/3. Okay, next I've got fractional and negative indices. So I'm asked to work out the value of 64 to the power of 2/3 plus 1/3 to the power of negative 3. So 64 to the power of 2/3. Let's work that out first. Remember, it's the root for the denominator and then to the power of whatever your numerator is. So I could write that as the cubed root of 64 to the power of 2. So that becomes the cubed root of 64 is 4. And if you forget your cube numbers, you're very rarely going to be asked for a cube number that is more than 7, I guess. So just think to yourself, 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 8. 3 times 3 times 3. You can actually just work it out in the exam if you haven't memorized them. But it would be really helpful if you could memorize them. So anyway, 4 squared is my first part, and then I'm asked to work out 1/3 to the power of negative 3. So remember that the negative indice means it's the reciprocal. So that is the reciprocal of 1/3 cubed. So what's 1/3 cubed? Well, 1/3 cubed would be 1 cubed over 3 cubed, which is 1 over 27. Therefore, if 1/3 cubed is 1 over 27, 1/3 to the power of negative 3 is going to be the reciprocal, and reciprocal means you flip it. So that would be 27. Another way you could do that is 1/3 to the power of negative 3 would be 1 divided by 1/3 cubed, which would become 1 times 3 over 1 cubed, which would become 1 times 27 over 1. So you choose which way works best for you, but we'd be left with 4 squared plus 27, which equals 16 plus 27, which would give you 27 plus 16, 7 plus 6 is 13, 2, 3, 4, 43. Okay, next we've got equations of a line, and we're dealing with perpendicular lines as well. So I'm told that the equation of line 1 is y equals 4x minus 5. And the equation of line 2 is not written in the y equals mx plus c form, but that doesn't matter because I can rearrange it. A key piece of information is that L1 is perpendicular to L2. So what you need to know is that the gradients of perpendicular lines multiply to make -1, or they are negative reciprocals of each other. So I need to find the value of k, and I must show how I got there. So what I can do is figure out what the gradient of L1 is. Now, every straight line is written in the form y equals mx plus c, where m represents the gradient and c represents the y-intercept. So in this line here, it's y equals 4x minus 5. The coefficient of x is 4, so therefore the gradient of line 1 is 4. Now I can work out what the gradient of line 2 is by using that piece of knowledge that perpendicular lines have gradients that multiply to make -1. So 4 times by something is going to give me -1, which means that something must equal -1 divided by 4. How else can I write that? That something is -1 over 4. And so the reciprocal, the gradient would be -1/4. Another way to do it would be, you know that you've got 4 and reciprocal of 4 is 1/4. So the reciprocal is, if you wrote this as a fraction, just flip it over and it's a negative reciprocal, so it'll be -1/4. So I know that the gradient of line 2 is -1/4, and I need to figure out what k is. So there's a few ways I can do this. I would probably start with just rearranging the equation so that it's in the form y equals mx plus c. So you've got 8y plus kx minus 16 equals 0. And you want to get it in the form y equals mx plus c, which means you're going to move everything from one side to the other to get y on its own. So the first thing we could do is add 16 to both sides. So I'd be left with 8y plus kx is 16. Then we could subtract kx. So you'd be left with 8y equals 16 minus kx. And the final part is you don't want 8y, you want it to be in the form y equals. So let's divide everything by 8. And I'm dividing one side, so that means I need to divide everything on the other side by 8 as well. So that would be y equals 16 over 2, which is 2, minus k over 8x. So I know that the gradient of line 2 is -1/4, and I know that must be equal to m, because the gradient of any straight line is y equals mx plus c, where m is the coefficient of x. So that means the number attached to the x. It doesn't matter which number comes first, which part comes first here, it needs to be the number attached to the x. So -1/4 must be equal to minus k over 8. So what I can do is just rearrange that. So I could multiply by 8. So -1/4 times by 8 is going to give me minus k. So that would be -8 over 4 is equal to -k. When I've got something like this, I can just multiply both sides by -1 in order to make my equation simpler. So I've got y equals -8 over 4 equals -k. You never want to have a negative subject. So if you do, times both sides by -1, because if you do something to one side and you do it to the other, it keeps it in the same, it doesn't change the value of the equation. So that would be 8/4 equals k. And what does 8 divided by 4 give you? 2. So therefore k must equal 2. So slightly difficult question in that you need to know the thing about perpendicular lines and their gradients. And then this equation has just been rewritten, not in its y equals mx plus c form. So it's up to you to change it into that. Okay, so in this question, I am shown a diagram with a sphere in it with radius r. I'm also given the formula for the surface area of a sphere, which is 4 pi r squared. And then I'm told that 3/5 of the surface area of the sphere is 48 pi. And the question is asking me to find the diameter of the sphere. So first of all, I can substitute what I know. So I know that the surface area of the sphere is 4 pi r squared, and that 3/5 of this is equal to 48. So 4 pi r squared times by 3/5 must be equal to 48 pi. So I'm using the information the question has given me to set up an equation. What I can do then is simplify this. So I could write that all as 4 pi r squared times by 3/5 equals 48 pi. 4 times 3 is 12, so that would become 12 pi r squared over 5 equals 48 pi. I could then multiply both sides by 2, so 12 pi r squared must equal 48 times by 5. If I use the doubling and halving method, double one and halve the other. So if I double this, it becomes 10, which is super easy to multiply by. And I'd have to halve this, and that would give me the equivalent answer. So 24 times 10 is 240, which means 48 times 5 must also be 240. So that would be 240 pi. And all I'm doing is just rearranging the equation. So the first step, what did I do? I multiplied both sides by 5. No, wait, here I times by 3, I simplified it. Here I multiplied both sides by 5. Then what am I going to do? I could work out, well, I could divide both sides by pi. So cancel. So that would be left with 12r squared must be equal to 240. I could then divide both sides by 12. So 240 divided by 12. Simplify it, that would be 120 divided by 6, and that would be 20. You could keep on doing it if you wanted to get 60 divided by 3 as far as you need to in order for it to click in your head. So the radius squared is 20, which then means that to work out what the radius is, I need to do the positive or negative square root of 20. It's an area. Well, we're dealing with real life, so it's going to be the positive square root. A radius, a length can't be a negative, so therefore it's going to be the square root of 20. Now, if I know that the radius is 20 or root 20, in any circle where I've got the radius, the diameter is always double that. So if I know what the length of the radius is, to work out what the diameter is, I'm just going to double it. So diameter is always 2 times the radius. So the diameter of this sphere must be 2 times root 20. Now it tells me to give my answer in the form a root b, where a is an integer and b is a prime number. This is essentially unnecessary information. Don't let it confuse you. Just simplify the surd. So 2 times root 20, let's simplify that. When I'm simplifying a surd, I'm always trying to think of 2 numbers that multiply to make it. Ideally, one of them is going to be a square number. So root 20 is the same as 4 times 5, 4 being the square number, which I could write as root 4 times by root 5. I could split the surd up because it's still being multiplied. The square root of 4 is 2. And the square root of 5, I can't simplify that. It's a prime number. So I'd simplify it to 2 times 2 is 4. So I'd be left with 4 root 5. Okay, so in this question, we're dealing with graphical inequalities, and there's two things that you just really need to remember that everyone forgets. It's that there's two types of lines that we can have when we're drawing these. So if your line is greater than or equal to, or less than or equal to, you draw a solid line. If it's less than or greater than, then you draw a dotted line. So this will make a little bit more sense when I explain what we're doing. So you've got three inequalities, and you need to define which region satisfies all three of them. So the first thing we do is we want to turn all of these into equations so that we can draw the lines of those equations. So start with the easiest one, because then you just make life a little bit easier for yourself. So we've got x is greater than -2. So x is greater than -2. Because it's greater than, it's going to be a dotted line. But what I'd recommend is drawing them in pencil first and then going over them in a straight line, because sometimes it's difficult to just remember all of that. So x is greater than -2. Where's the line? X equals -2. That line would be over here because it crosses the x-axis at -2, which means every x coordinate, every coordinate on this line, the x coordinate is going to be -2. So it's going to, here I've got -2,1, -2,2, -2,3, so forth. So all of the x coordinates are -2 anywhere on this line. That's why it's called the line x equals -2. So you've drawn it in pencil. Then you can go over it in pen and draw a dotted line. So we've drawn that bit. Now we need to define whether which side satisfies the inequality. So the inequality is that x, so the x coordinate has to be greater than -2. So over here is your x-axis. These coordinates are all greater than -2. And these coordinates, or the x coordinates, are less than -2. So therefore, over here, anything on this side is satisfied by the inequality, and anything on this side is not, because all of these coordinates are less than -2, and x has to be greater than -2. So what we can do is shade this part of the region, shade it off, because we know that this does not satisfy our inequality. Only anything on this side does. So I've got rid of the first one. Next, we could try this one. It doesn't really matter which one you do first. I'd always go, if you have a single one, like a vertical or horizontal one, like x equals or y equals, I'd always do that one first. It just makes your life easier. So we've got 2y plus 6 is greater than x. So I'm going to turn it into equals x, just to turn it into an equation so I can draw it. And what you always want to do is to have each of your lines in the form y equals mx plus c. So you rearrange them so that y is the subject. So the first step I'll take to rearrange this is to take 6 from both sides. Then I'll be left with x minus 6. And the next step I take is I divide by 2. Now be very careful, because some people only divide parts of the equation by 2. Each part needs to be divided by 2. So anything that has a plus or a minus in between it, they're separate terms, and therefore each one of those need to be divided by 2. So that would be left with y equals x divided by 2, take away 6 divided by 2, which can be written as a half x. Well, you decide which you prefer. A half x minus 3. X over 2 and a half x are equivalent. So I know that the y-intercept, c is the y-intercept, so I can use this to help me know that the line is going to cross at 0, -3. So that's one coordinate I already know. Now, if you feel confident doing these, then you can just pluck a few coordinates and substitute them in. But if you don't, what I would recommend is just doing your table of values. So you've got x and y. Over here, you've got -2. I am just going to start from -2, 0, 2, 4, 6. You could do all of them if you wanted to. This will just save you a little bit of time. So I'm going to start with the largest positive. So a half of 6 is 3. 3 take away 3 is 0. Half of 4 is 2. 2 take away 3 is -1. a half of 2 is 1. 1 take away 3 is -2. So you might notice a pattern. You might realise that each time you're subtracting 1. So you could easily predict what the next 2 must be. And you know that this one is correct because the y-intercept is -3, and it makes sense at -2, but we can double check it by saying half of -2 is -1, -1 minus 3 is -4. So we've got our coordinates, so -2, -4, 2, -2, 4, -1, and 6, 0. I could also predict it for -4, so half of -4 is -2, -2 minus 3 is -5. Just to make it a little bit more accurate. So you join it together and wait. So you join it together with a straight line, ruler, pencil, and then you look back at it and you think to yourself, okay, I've rearranged this equation just as an equation, but as an inequality it would remain as y must be greater than x minus 3. I'm keeping this exactly as it is. All I've done is rearrange it. You could also rearrange it first and then turn it into an equation. It's up to you. So because it's greater than, it means it needs to be a dotted line. So I go back and with pen I draw the dotted line over there. Now y needs to be greater than the line. So let's label the lines just to make life a little bit simpler perhaps. This is the line x equals -2. This is the line y equals a half x minus 3. So my y coordinates need to be greater than the line. So I look along the y-axis. Over here, the y coordinates are greater than the line. Over here, they're less than the line. So I know that anything underneath the line would not satisfy my inequality. So I can shade that bit out. And the last one is already written in the y equals mx plus c form. It's just a little bit, it's got fractions in it, which makes it a little bit more difficult. And I'm just going to write it as 3 over 2x because it's just, it doesn't really make a difference. It's just written in the proper form. So once again, I do my table of values. I've got x and y. And as an equation, this would just be y equals minus 3 over 2x take away 2. So once again, I can pick some coordinates. So I'm going to go -4, -2, 0, 2, and 4 and see if I need any more. So when x is 4, 4 times -3 over 2 is -12 over 2, which is -6, and -6 minus 2 is -8. So I don't have that on the grid. So let's try 2. So 2 times 3 over 2 is -6 over 2, which is -3. -3 minus 2 is -5. So I've got 2 and -5. Then I've got 0. I know that the y-intercept is going to be -2, so automatically I know that's going to be -2, but you can still work it out. I then know that -2 times by -3 over 2 would give me +6, because a negative times a negative gives you a positive. So 6 over 2, which is 3. 3 take away 2 is 1. So -2, 1. And then -4 times by -3 over 2 is 12 divided by 2, which is 6. 6 take away 2 is 4. So that would be -4, 4. You join your line in pencil, and then you know that it's going to have to be a solid line. So we join that together. The region that is satisfied, it's the y coordinates have to be less than or equal to 2. So the y coordinates have to be less than the line. So anything that is greater than can get shaded out, which leaves me with this small region here, which you'd label R. So the key with all of these is you draw them, you shade out the bit that you don't want, that doesn't satisfy your inequality, and it's going to leave you with a really small region, and that's the region that satisfies the inequalities. Okay, so here we've got inverse functions. So I'm told that the function f is given by f of x is 2x cubed plus 5. And I need to show that, which means I need to show each step of my working that the inverse of f of x, with f of 21, is 2. So the first thing I want to do is work out what the inverse of x is. So the way I do that is over here, I've got f of x equals 2x cubed plus 5. The first thing I do to find the inverse is I change my f of x and I make it a y. So I'm going to say y equals 2x cubed plus 5. And the next thing I do is I just switch y and x because I'm trying to find the inverse operation. So I'm going to switch them around. So I'm going to say x equals 2y cubed plus 5. And I'll just actually maybe turn everything else so that you see that it's just x and y that are switched. And then what you do is you rearrange it to make y the subject. So you'd be left with, the first step you could do is take 5. So x take away 5 is 2y cubed. The next step would be to divide by 2. So x take away 5 divided by 2 equals y cubed. And the final step to make y the subject would be to do the cubed root. So the cubed root of this whole thing is y. So when you get to your final bit, what we do is we just switch y, we change it to f of minus 1 of x. So the inverse of x is going to be the cubed root of x minus 5 over 2. So I found the inverse of x. And what I do now is I'm going to substitute. I've been told that I want to find the output when the input is 21. So f of minus 1, 21, what I'm going to do is wherever I see an x, I'm going to put 21 instead. I'm going to substitute. So that would be 21 take away 5 divided by 2, which is the cubed root of 21 take away 5 is 16. So the cubed root of 8, 16 divided by 2 is 8, and the cubed root of 8 is 2. So you found first step 1, you found the inverse of x, and then you've substituted 21 into the inverse. So the key is find the inverse and then substitute whatever's in here into your equation. So wherever you see an x, you substitute that number. Okay, next we've got some composite functions, which is where we're putting a function into a function. So I'm told the functions g and h are given by g of x is x plus 3 and h of x is x squared. I need to find the values of x for which hg of x equals this. So first of all, what does it mean when I've got a composite function? It means I've got g of x, and I'm going to put it into h of x. So what is g of x? G of x is x plus 3. So this is what I'm going to put into h of x, which is x squared. So what this means is this gets put into wherever I see an x. So I'm substituting the whole function g of x into h of x. So hg of x is going to become x plus 3, because I'm putting that wherever I see an x, squared. And what I could do is then expand that. So that would become x plus 3, which equals x squared plus 6x plus 9. I'm doing it a bit quickly, but you can take it slower. So I know that hg of x equals x squared plus 6x plus 9. And I need to find the values for which hg of x, which I've just said. So I know that hg of x is equal to x squared plus 6x plus 9. And I need to make this equal to this. So I'm going to say x squared plus 6x plus 9 is equal to 4 minus x squared minus x. Then I just have a double-sided equation, and all I want to do is rearrange it, simplify it, and figure out the values of x. So what can I do first? Well, I could add on x squared to both sides. So I'd be left with 2x squared plus 6x plus 9 equals 4 minus x. I could then add on x. So I've got 2x squared plus 7x plus 9 equals 4. And then I could subtract 4. So 2x squared plus 7x plus 5 equals 0. So now I've got a quadratic. And whenever you've got a quadratic that is equal to 0, to solve a quadratic, what you do is you factorize. So to solve a quadratic, you make it equal to 0 and then you factorize it. So I've got 2x squared plus 7x plus 5 equals 0. There's loads of ways I could factorize this. You could use the AX ABC method. I'm just going to do that way actually. So you could also do, I don't know which one to show you. For the non-calculator paper, actually, let's use the grid method. So what does this mean? 2x squared is what I'd have in here. Actually, without explaining it, whatever. Okay, so 2x squared is over here. It means that I need to have 2x times by x to make 2x squared. These two are going to need to sum to 7x. And then this quadrant is going to need to be 5. So I know that one of my brackets is going to be 2x. The other is going to be x. And then I know that one of these numbers has to be 5 and the other has to be 1 because they're the only ways that you can make 5. So what I can do is trial a few of them. So let's say I tried 5 here and 1 there. 5 times 2x is 10x. X times 1 is 1. So 10x plus x is 11x. So that doesn't work. So I can switch them around. So if this is 5 and this is 1, 2x times 1 is 2x. X times 5 is 5x. So 2x plus 5x makes 7x. So I know that it would be 2x plus 5 or x plus 1 must equal 0. That's just a way that sometimes works for the non-calculator paper if you don't like the other method. If not, then just do the method that you like. So I factorised my quadratic and then I make it equal to 0. So each bracket I make equal to 0. So x plus 1 equals 0. Therefore, x must be negative 1. And 2x plus 5 equals 0. Therefore, 2x is negative 5. Therefore, x is negative 5 over 2. So that's my two values. Okay, next we've got a vectors question. So I'm told that OABC is a parallelogram, which is important because if you've got a parallelogram, then you've got parallel lines. So I know that if this vector is A, this one is also going to be A, and this one is also going to be C. So I can just label that quickly. I'm told that OA is A, OC is C, so that's already labelled. And then I'm told that P is the midpoint of the line OB. So OB would be this line here, and halfway would be the point P. I'm told that ABD is a straight line. So ABD, I don't know where D is. It's a straight line, so that AB to BD is K to 1. Okay, so ABD is K to 1. Given that PD is a half A plus 17/10 C, find the value of K. Okay, so what I want to do here is first work a few things out. So I've been given OB as a line and told about P. So OB is probably going to be important. So we can start by trying to figure out what the vector OB is. So to get from O to B, remember with vectors, you can only go along given points. So we only know, we can't do this because we don't know what that is. So we have to go along the lines that we know. So how can I get from O to B? I start from O and then I can go along here, which is A, and along here, which is C. So OB can be expressed as A plus C. That must mean that OP is going to be half of this, half A plus C, which I could write as a half A plus a half C, or I could leave it in brackets, whichever one works best for you. And that also means that PB is also equal to it because it's the halfway point. So if you know a vector and you know the halfway point, you just half the vector, or you multiply it by a half. So that's the first bit. I know that PD is this. So to get from P to D, I've been given that vector, which is a half A plus 17/10 C. I know what PB is. So how do I get PD? I go along the route PB plus BD, which I do not know. So I do know what PB is. So I know, where shall I write it? That half A plus 17/10 C is equal to PB, which I said is a half A plus a half C, plus BD. So let's think about that. If I rearrange that, if I take away a half A, I'd be left with 17/10 C equals a half C plus BD, and then take away a half C. So 17/10 take away a half is the same as 17/10 take away 5/10. I'm just making it an equivalent fraction, so I times that by 5, which gives me 12/10. So if I take away that, that must mean that BD is equal to 12/10. So if BD, 12/10 C, sorry, BD is equal to 12/10 C, I need to figure out what it is as a ratio. So let's get rid of all of this. I know that AB is C, because that's already been given to me. And I know that BD is 12/10 C. So BD is 12/10 C. And that ratio is K to 1. So essentially, I could say that's 1C to 12/10 C. So AB to BD is 1 to 12/10. And I need to get it in the ratio K to 1. So I need to figure out what I am multiplying or dividing this to get to 1, and to turn any number or fraction to make it multiply. Okay, so in this question, I'm asked to show that this surd can be written in the form a plus b root 7. So essentially, all I'm being asked to do is to simplify this surd and get it in this form, and show all of my working. So whenever I've got a surd and I want to simplify it, generally, I'm going to want to rationalize the denominator. There's a few things that we could do first. We could either simplify it first or simplify it at the end. It doesn't really matter which you do, it depends on your preference. So I might start by simplifying what I can simplify, just so that it makes my life a little bit easier. So I've got root 112. So I'm going to want to simplify this. To simplify it, I split it up. Ideally, I want to look for a square number. If I can't recognize something that's a square number inside it, I could keep splitting it until I do. Okay, so 112, I could split into, this isn't necessarily instantly recognizable. So 2 times by, if I divide 112 by 2, 2's into 11 go 5, remainder 1, 2's into 12 go 6. So that would be 2 times 56. And then I could split that into 2 times 2 times 56. So you don't have to instantly recognize the square number. Sorry, and that wouldn't be 56, it would be 28. Again, if you need to, you've got the bus stop method. So 2's into 5 go twice, remainder 1, 2's into 16 go 8. So what I can do here is, ideally the best way is recognize the square number and then use that. But if not, you can do it this way. So I've got root 2 times root 2 times by root 28. I know that this is then going to become root 4 times by 28. So that is automatically going to become 2 because the square root of 4 is 2. So 2 times by root 28. Now let's see if I can simplify this any further. Root 28, well, I could do 4 times 7. So always try and look for a square number. If you can't, you can do the method that I showed you. Keep on dividing it and then manipulating it. So that would become 2 times root 4 times by root 7, which is 2 times by 2. Root 4 is 2. And root 7 is a prime number, so I can't simplify it any further. 2 times 2 becomes 4 root 7. So I've just simplified root 112 just to make my life a little bit easier. Otherwise I'd have to be multiplying by 112, which might be a little bit trickier. So I know that root 112 is 4 root 7. So let's put that into the surd. So I've got 4 root 7 minus 2 root 7 over 3 root 7 minus 7. So I could simplify this. Remember, when you're simplifying surds, you can treat it like algebra. So for instance, 4 root 7 take 2 root 7 is the same as saying 4a take 2a. So 4a take 2a would give me 2a. So 4 root 7 take 2 root 7 is going to give me 2 lots of root 7. So the numerator would be 2 root 7 and the denominator would remain as 3 root 7 take away 7. So I've simplified my surd to make my life a lot easier. I would always start by simplifying what you can. So now that I've got 2 root 7 over 3 root 7 minus 7, when you're simplifying surds, you always want to rationalize the denominator. And what that means is you don't want a surd on the denominator. You want it to be a rational number, which means an integer. So a non-surd. So what you do when you're rationalizing the denominator, if it's something simple like, let's say it was 2 root 7 times by root 3, you'd multiply the whole fraction by that denominator and then do that. But here we've got 2 terms. So if you've got 2 terms, what you do is you multiply the whole surd by its conjugate, which essentially means the denominator, except you switch the sign. It's the inverse sign. And the reason for that is because when we expand the brackets, the terms cancel out. Hence, we get rid of the surd. So I'm going to multiply it by the conjugate, which means I'm going to have 2 root 7 times by 3 root 7 plus 7 as my numerator, and then 3 root 7 minus 7 and 3 root 7 plus 7 as my denominator. I can then expand this bit by bit. So 2 root 7 times, so you can, and I would recommend, especially if surds aren't your, what's the word? Forte, just do loads of working for it. So you've got 2 root 7 times 3 root 7. You can split it up like that. So we're multiplying 2 root 7 times 3 root 7. 2 times 3 is 6. And then you've got root 7 times root 7. And whenever you've got a surd multiplied by itself, it like unsurds itself. So for instance, the easiest one to think about is root 25 times root 25. What does that become? Well, the square root of 25 is 5. Square root of 25 is 5. So that becomes 25. Hence, square root of 25 times square root of 25 is 25. So therefore, using the same logic, square root of 7 times square root of 7 is going to become 7. So the first part of my expanded bracket becomes 42. So that would become 42 plus, and then you've got 2 root 7. multiplied by 7. So again, treat it like algebra. 2a times by 7 would become 14a. So that would become 14 root 7. And then we expand the double brackets. So 3 root 7 times 3 root 7. So remember, you do 3 times 3 times root 7 times root 7. 3 times 3 is 9. Root 7 times root 7 is going to become 7. So that would be 63. 3 root 7 times by 7 is going to give you 21 root 7. And minus 7 times by 3 root 7 is going to give you minus 21 root 7. Then we've got minus 7 times 7, which is minus 49. So the reason I did the conjugate is because that means that I have two terms here that are going to cancel out. So that's going to become 42 plus 14 root 7 over 63 minus 49. So 3 take 9 I can't do. 13 take 9 is 4, so that would be 14. Okay, so I've simplified my surd and I've got this far. So let's just write this up here. So I've got to 42 plus 14 root 7 over 14. And now let's see what I can do. I want to write it in the form a plus b root 7, where a and b are integers. So let's see what we can do. We've got 42 plus 14 root 7 divided by 14. So I can see if I can divide everything by 14, because I can see that 14 divided by 14 cancels out here. That would give me 1. So 42 divided by 14, does that work? Let's try simplifying it. That becomes 21 divided by 7, which is 3. So I know that if I divide by 3, or if I divide by 14, I'd be left with 3 plus 1 root 7 over 1. I mean, it will cancel out. So it'd just be 3 plus 1 root 7. I've written 1 root 7 because it says give it in the form a plus b root 7, where a and b are integers. So if it wants an answer for b, so the value of a is 3, the value for b is 1. But if you wrote it as 3 plus root 7, that would also be fine. So that's how we do that one. Okay, so here we've got to prove algebraically that a recurring decimal can be written as a fraction. So whenever we're doing this, what we do is we start by labeling our decimal as x. So if x is 0.121 recurring, I can then manipulate it by multiplying it by a power of 10. So I know that x is 0.121, therefore 10x is going to be 1.21 recurring. 100x is going to be 12.12 recurring, and 1000x is going to be 121.21 recurring. Now, the reason I've done this is because people always get confused as to how much they should multiply it. So just start with x, multiply it by 10, multiply it by 100, multiply it by 1000. And then you should very easily see which two would combine so that if you subtract them, they cancelled out. So what you want is for the parts after the decimal point to be equivalent, because if they are, when you subtract them, you'd get 0. So I can see that 10x and 1000x both end up with 0.21 recurring afterwards. So I know that I would have needed to multiply at least by 10 because this part is not recurring. So I'm going to choose 10x and 1000x, and I'm going to write them out here. I'm going to write 1000x first because that's the largest number. So 1000x is 121.21 recurring, and 10x is 1.21 recurring. And if you line them up, you can see that the recurring part is equivalent. So I can then subtract these to work out what the difference is. So 1000x take away 10x is 990x. And 121 take away 1 is 120. So anything, as long as the thing after the decimal is equivalent, when you subtract it, it's going to become 0. That's why we get a nice clean number and we can turn it into a fraction. So I know that 990x is 120. Therefore, if I divide both sides by 990, x becomes 120 over 990. Now it's asked me to prove that it can be written as 4 over 33, so I know I'm going to have to simplify it. So 120 over 990, I could start by just dividing by 10. So that would become 12 over 99. And then it's given me a clue. So I'm showing that I've divided by 10 over here to simplify it. And I know it's going to have to become over 33. So what do I divide 99 by to get to 33? I divide by 3. And 12 divided by 3 is 4. So that's how we do that question. Okay, so in this question, we're being asked to sketch the graph of a quadratic. Now, when we're sketching a graph, there are 3 key things that we want to figure out. So the first thing is the y-intercept, which is the easiest thing to work out. Next thing is the roots, which is essentially the x-intercept, so where the graph crosses the x-axis like that. And then finally, we've got the turning point, which is where the graph turns. So it's either going to look like this over here, or it's going to be a graph like that, where the turning point is over here, depending on whether it's positive or negative. So I want to figure out these 4 things. They're the 3 things. They're the key things that I need for my graph. It says, ensure your sketch shows the coordinates of the turning point. So it's made that clear to me, and the exact coordinates of any intercepts with a coordinate axis, so the y or the x-axis. So let's start off by figuring out what the y-intercept is. So the y-intercept is essentially when you've got a coordinate axis, your y-axis is here, your x-axis is here, and your y-intercept is where the graph crosses the y-axis. So anytime it crosses the y-axis, the x-coordinate is going to be 0. So to figure out the y-intercept, what you do is you substitute, it's when x is 0, so let's substitute 0 into the quadratic. So 2 times 0 squared is going to be 0, 12 times 0 is 0, and then you're left with positive 7. The quick way to figure out what the y-intercept is, it's just going to be the in the form ax squared plus bx plus c, it's c, just like it is for a straight line. So the y-intercept is going to be 0, 7. Next, what I can do is either do the roots or the turning point. In order to do the turning point, you're going to need to complete the square. And if you complete the square, you can also figure out the roots. So I'm going to start with the turning point, and I'm going to need to complete the square for that. So I've got y equals 2x squared minus 12x plus 7. And to complete the square, this one's a little bit of a trickier one because it's got a coefficient of x squared. But it doesn't matter. I'm just going to focus on this part when I'm completing the square. And I'm going to take out the coefficient of x. So I'm going to divide everything by 2. So I'll be left with 2 brackets x squared minus 6x plus 7. So I'm just dealing with this part here. In fact, I can ignore the plus 7 for now and add it on at the end. So I can now complete the square. What do you do when you're completing the square? You halve the coefficient of x, so that would become 2 brackets x squared minus 3. Oh, what am I doing? Sorry. So that would become 2 brackets x minus 3 squared minus 9. So that's just me completing the square. Remember, you halve the coefficient of x and then you subtract this squared. So if you need more advice on completing the square, we can go through that in a separate video. But that's the completed the square form. I'm then going to add 7, bring this back, and I'm going to expand everything over here. So 2x minus 3 squared minus 18 plus 7 becomes 2x minus 3 squared minus 11. So now that it's in the completed square form, for your turning point, your x coordinate is going to be the inverse of whatever's inside the bracket. So it's negative 3, so my x coordinate would be positive 3, and your y coordinate is going to be whatever this is. So that's minus 11. So hopefully you're familiar with that. And that's the turning point. Oh, and I just undid it, so I can't remember what it was. it was, okay, so the completed the square form is 2x minus 3 squared minus 11. So I can also use this to figure out what the roots are, because to figure out what the roots are, which is where it intercepts with the x-axis, I need to substitute y equals 0. So essentially, I make this quadratic equal to 0. So 0 equals 2x minus 3 squared minus 11. So I just made the quadratic equal to 0. And then I want to solve it for x. I already know that this quadratic can be expressed in this form, in the completed the square form. So I'm just going to go with that to make my life easier. So let's solve it. What am I going to do? First, I'm going to add 11 to both sides. So 11 equals 2x minus 3 squared. The next thing I can do is divide both sides by 2. So 11 over 2 is x minus 3 squared. Next thing I can do is square root both sides. So the square root, and remember it's going to be positive or negative, because when every square number has a negative and a positive square root. So that's going to be x minus 3. So the last thing I do is I add 3 to both sides. So the x coordinates are going to be 3 plus or minus 11 over 2. That means that one of the coordinates would be 3 plus 11 over 2, and one would be 3 minus root 11 over 2. So they're my two coordinates. So I've got all of the information I need in order to sketch this graph. So I'm going to sketch an x-axis and a y-axis, and then I need to label the key points. So I know that the y-intercept is 0, 7. I know that the turning point is 3 minus 11. So let's say maybe minus 11 is here and 3 is here. So that would be my turning point. And then I can work out where my, roughly where my coordinates will be. So square root of 11 over 2, obviously we can't do in our heads, but we can estimate it. So I know that 11 divided by 2 is 5.5. So I'm looking to see what the square root of 5.5 would be. So let's just use our square numbers so that we can estimate this. I know the square root of 4 is 2, the square root of 9 is 3, therefore the square root of 5.5 is probably going to be somewhere roughly around 2.2. So I know that they're both going to be positive roots, because if I had 3 plus 2.2, that would give me 5.2, and if I had 3 minus 2.2, that would give me 0.8, so it'd still be in the positive quadrant. So let's write those coordinates down as well. So I've got 3 minus root 11 over 2 and 3 plus root 11 over 2. And then I'm just going to join it all together with a nice curve. So it's just a sketch, but the key point is that you've labeled everything and made it really clear. And the key things to remember for the sketching a curve, working out the turning point, is the turning point, you complete the square. The roots is when y equals 0, so you make it equal to the quadratic equal to 0 and you solve it. And the y-intercept is when x equals 0. Okay, so you've made it to the last question. So if you've come this far, then really well done. And we've got a shaded region kind of question with a little bit of geometry problem solving. So the key thing is to extract as much information as I can from this question and think carefully about what I'm told. So I'm told that the diagram below shows a regular hexagon of side length 6 centimeters. Now this is really, really important, because the fact that it's a regular hexagon means that all sides and interior angles are equal. That's for any kind of regular polygon. It means that all sides are equal and all interior angles are equal. So I know what the size of this angle here is, I know what this angle here would be, and so forth. So I know that each side is 6 centimeters. And for a regular hexagon, what would I do? I do n take 2 times by 4. So it's 6 sides. So I do 4, sorry, not times by 4, times by 180. 4 times by 180 is 720, and 720 divided by 6 is 120. So I know that this is 120 degrees, and I know that this is going to be 60 degrees because I'm told that the shaded region below is formed by a tangent to the circle and a mirror line of the hexagon. Now, I might not actually need all this information, but it's always helpful to just see what you can figure out instantly just from the question that you've been given. Now, I'm told that a circle of radius 3 centimeters is removed from the center of the hexagon, which must mean that this is the center of the hexagon. And that the shaded region below is formed by a tangent to the circle, so over here, and a mirror line of the hexagon. So that means it splits the hexagon exactly in half. Now there's loads and loads of ways that we can do this, so we're just going to go through one of them. So the first thing that should strike me is some knowledge that a lot of people just seem to forget. But if I've got a regular hexagon, then it forms 6 equilateral triangles. So if I think about it and I split this over there, that's the length of, well, that's halfway from the center of the hexagon to the outside, and this is also going to be halfway from the center to the outside. So is this, so is this, so is this, and this. So therefore I've got 6 equilateral triangles. So this is the bit of knowledge that some people might overlook, and unfortunately it's a really important piece of knowledge. So I know that I can split this into 6 equal triangles, equilateral triangles, so that I can use to help me. Now, if they're equilateral triangles, I know, so I didn't even actually need to do the regular hexagon, I know that each of these angles are going to be 60 degrees because angles in an equilateral triangle are 60 degrees. So that's a really good piece of knowledge that I can use. I also know that the side lengths, if this is 6 centimeters and they're equilateral triangles, that must mean that this side is 6 centimeters and this side is 6 centimeters. So I can use this to help me figure out what's going on. So I have all of that knowledge, and now what I can do is think, I've got a shaded region. So whenever you have a shaded region, ideally what you want to do is work out the area of the whole shape. So I'm going to say that that is my whole shape. So I want to work out the area of this and then subtract anything that's taken out of it. So over here I've got half a circle, so I'm going to subtract half a circle from this. So to pick up some easy marks, even if you look at this question and you're like, I have absolutely no idea where to start, you don't know the thing about the hexagons, you still could work out the area of the circle. So I know that the circle has a radius of 3 centimeters. So I'm going to say area of a circle is pi r squared. The radius is 3, so that would be pi times 3 squared. So that would be 9 pi. So the area of the full circle is 9 pi, but I know I'm going to be subtracting half a circle from my shaded area. So therefore, the area of half the circle is going to be 9 pi over 2, and this is going to come in handy once I figured out what the area of the shaded part is. So now I'm saving that for later, and now I just want to focus over here. So I've already shown that I can split this up into 3 equilateral triangles. Now I've been told that the radius is 3 centimeters, which means this length here must be 3 centimeters. So these triangles I can deal with separately, and this triangle I'm going to deal with separately. So I've got 2 types of triangles, 6 with 60 degrees, 6, 6, and obviously 60 degrees everywhere here. And then I've got this right angled triangle, which I could use a separate thing for, or I could know that this is an equilateral triangle and therefore I just half the area of the triangle, but I'm gonna do it the slightly harder way just in case you don't notice that. So let's work out the area of these 2 triangles. So how do you work out the area of a non-right angled triangle? The area for a triangle is half AB sine C. So I know that the values of all of the sides are 6. So A and B is 6. And I know that every angle is 60. So I'm going to write half AB sine 60. Now, I'm not going to go through the trigonometric values, but you do need to know sine 60 is one of the trigonometric values that we need to know. So, and sine 60 equates to root 3 over 2. So that would be half times 6 times root 3 over 2. If you don't know your trigonometric values, there's a video you can watch on how to figure those out. So I've got that. I'm going to simplify this. I've got half times 36 times root 3 over 2. And then that becomes 18 root 3, half times 36 over 2. So the area of one triangle is 18 root 3 over 2, which can simplify to 9 root 3. So the area of a triangle is 9 root 3. I've got two of them, so I'm going to do 9 root 3 plus 9 root 3. And then I have the final little bit here. So this area here is 9 root 3. This area here is 9 root 3. And I'm now going to try and work out this area here. So you could just halve one of the triangles, but just in case you didn't pick that up, we know that this length here is 3. We know that this length here is 6. So we could use Pythagoras to figure out what this length here must be. So we've got 6 squared, take 3 squared is here, c squared. So 36 take 9 is 27. So therefore c is going to be the square root of 27. So could I simplify that? Well, that's 9 times by 3. So that would be 3 root 3. So I know that this length here is 3 root 3. How do you work out the area of a triangle? You do base times height divided by 2. So I'm going to do base 3 times by height, 3 root 3 divided by 2. So that becomes 9 root 3 divided by 2. And that's the same thing you would have got if you'd just halved the area here. But just to confirm, that's how we would have done that and why, just in case you were worried that it wasn't half of the equilateral triangle. So what I need to do is I've got this triangle plus this triangle plus this triangle. That gives me all of this, the shaded region. And then I'm going to subtract this area, the area of the circle. So minus the area of the half circle. So let's write that in numbers. I've got 9 root 3 plus 9 root 3 plus 9 root 3 over 2. Take away, what was the area? 9 pi over 2. So let's simplify that. That would become 18 root 3 plus 9 root 3 over 2. And we could simplify that even further. Take away 9 pi over 2. So 18 root 3, I could write as 36 root 3 over 2, because 36 divided by 2 is 18. Plus 9 root 3 over 2. They're now fractions with the same denominator, so I can add them. So that would give me 45 root 3 over 2. So this bit has simplified to 45 root 3 over 2. And then I just need to subtract 9 pi over 2 from that. So my final answer would be 45 root 3 over 2. Take 9 pi over 2, which you could bring together as 45 root 3. Take away 9 pi over 2. And that's how you'd do that question. So it might seem quite tricky to begin with. The key thing is that you need to know your exact trigonometric values in order to be able to access this question. But even if you look at it and you freak out, it's the final question. So just see if there's something you can work out. You could have worked out the area of the circle. You could have tried and worked out one of the triangles. You could have done loads of things. The key is you start by labeling exactly what you know, and hopefully that makes it a little bit easier. So that is the end of this predicted paper. It is obviously just an extra practice paper to help you with the exam that's coming up tomorrow, but hopefully that was helpful. And if any of the questions you want more clarification on, let me know and I'll make a quick video to explain. But good luck with your exam tomorrow.